All right, so today we are going to finish off our navigation exercises with visual navigation. You got the visual navlog coming around to you. We're going to be working on a particular flight, but we want to talk about some points that you should know about with your VFR charts here. And for today, want to make sure that you've got a flight computer, a plotter, your calculating device, and your brain, obviously, gotta have that today. You will need your knowledge test supplement as well later, as we will have another opportunity for group activity, more extra credit opportunity with the navigation visual game. Talk about your charts. Now, for the most part, you're likely using a digital version of the sectional chart. That's absolutely fine. They still produce the paper charts. There have been some changes to how they produce these charts. I want to make sure you're aware of those. And a few other details that you should know about. Okay. If you have any questions on charts, we have a discussion area for you. Scaling on these is 1 inch of your chart is 500,000 inches. So obviously that's going to be the printed chart, right? Your digital chart, you can zoom in and out, and that kind of would affect that scaling a little bit. So that means 1 inch is just under 7 miles, 6.86 nautical miles. That's just some trivia information for you, right? Our latitude marks are laid out on a 1 nautical mile scale. I'm going to show you a little bit later on how we can use those latitude marks for actually measuring distances on charts. And here's the big change. Your charts are issued every 56 days now. That is a big change. They used to be printed, issued every 6 months. They've gone to 56 days now. And they're only valid for 56 days. So if you are getting a paper chart for some reason, it's got a lot shorter duration. So why? Why did they make that big change? And it has to do with the NOTAM system. Notices to Air Missions, right? That's the new name for NOTAMs. There's a lot of NOTAMs out there that deal with charts and changes on the charts. And that's been cluttering up the NOTAM system. So they decided, let's simplify things by printing these charts, whether it's a digital print or a paper print, every 56 days and incorporate changes in the NOTAM system. So again, that's the big change, and that occurred last year, actually. So you may not have been aware of it. As certain sectional charts have timed out of their 6-month cycle, that's when they started to implement the 56-day cycle for them. Of course, we're laid out from the 3-dimensional globe on a 2-dimensional piece of paper. In order to do that, we have to use latitude and longitude lines, okay? Using the Lambert projection models, which do distort certain aspects when you take a 3-dimensional globe and put it onto a 2-dimensional sheet of paper. But our system here does a nice job of helping you visualize relationship-wise, and for the most part, size of the different areas that you're looking at. So just to review, our latitude lines are the ones, if we start at the equator, they're the ones that run parallel all the way up to the poles. So we're talking about our lines of latitude here. And we have an equal space between these. And because they're equally spaced, the tick mark distances here are all 1 nautical mile spacing. So we can go all the way from the equator up to the pole with a 1 nautical mile spacing. Now the lines of longitude, and one of my early teachers taught me they run the long way around the planet from pole to pole. they're not equally spaced. Where at the equator, we have the greatest distance between our lines of longitude. And as we go north or south, that distance then decreases. So that creates a little bit of a distortion on our charts. And so we do take that into account with how they're printed. But keep in mind that the distance between these cannot be used for any sort of measuring. Since our lines of latitude here are parallel to each other, and they got that equal spacing between them, that means the tick marks that represent the lines of latitude are equally spaced at 1 nautical mile each. So regardless of what you're looking at, whether it's a reprint that's not to scale or it's a digital version that you zoomed in on, these tick marks are always 1 nautical mile spacing. So that means if you don't have a scaling on the actual chart, or if you don't have a plotter, or you're looking at a reproduction that's not the size, this is always going to work for you, measuring distances with these tick marks. And we're going to be using this later on a couple times today in our lesson here. Okay. So you should have brought this with you, whether I recommended that you print it. If you only brought it digitally, it'll still work for you. Well, we're going to measure the distance between these locations. What we kind of laid out is starting at the middle of Harvey Lake there, going to the middle of Silver Lake. And how we do that is we're going to take a piece of paper and we're going to line it up. Oh, hold on. Yeah, take a piece of paper, we're going to line it up along our intended course. And we're going to put a couple tick marks down. One of them is representing the departure point, and the other one's representing your destination. So I'll give you just a moment to get that first step down. Again, we'll be utilizing this later on in our lecture and in our group activity as well. Then we're going to take and move that paper with the tick marks on it and line it up on the longitude line, okay? Why? Because that's where your tick marks are for the latitude. Okay? And then we can start laying out our distances. So we got a tick mark here. We see tick marks spaced every 5. Right, and then we would keep going. Now mine's not the scale here, so I'll give you a moment to go ahead and count, make up your tick marks. I recommend just laying them out every 5, put a tick mark every 5 miles on it, okay. And then you'll be able to count the last number of tick marks. Give you about another minute here. All right, so you should be coming up with something in the 70-ish range. Won't tell you the exact answer right now, but you should be coming up something around 70-ish miles. Okay. On your FAA charts, they are not reproduced to scale, so you probably are not going to be able to use your plotter on them. It could be close, but the FAA does provide a scale at the bottom of each of those sectional charts that they've reprinted for your knowledge test guide. So very simple to use those. You would do the same thing, put tick mark down between whatever points you wanted to measure, and then you slide your paper down to the scale. And what you're going to do is you're going to make sure that the one tick mark is on one of the lines here. Got it, in this case on 30, and you want the other end to hang over to the left side of 0. And the reason you're doing that is because each of these tick marks on the scale is 1, so it makes it a lot easier to count the number of miles. So in this case, we see 36 miles between, I got 30 miles from the 30 mark to 0, and then another 6 tick marks there. That makes 36 miles is the distance. So you got a couple ways to measure distances. Just remember your plotter is likely not going to be to scale on these things. I know VORs are going to be a lot fewer in the future here as we move towards minimum operational network. But when you do see them depicted on the sectional chart, keep in mind that they are aligned with magnetic north. And that magnetic north alignment was when they actually installed or updated the unit and verified its operation. Magnetic north does move, but the radials are still based upon when it was installed, whatever the magnetic variation was at that time, or if they did an update to it, whatever it was at that time. Roughly about every 10 years, they recalculate magnetic variation and update charts with it. Lately, the magnetic North Pole has been moving very quickly out of Canada and back towards Siberia. So it's really given cartographers a run for their money and trying to figure out how to depict magnetic variation. Just another thing to point out, if you are using the VOR system for navigation, then you need to use whatever's published here. For example, there's an airway coming out of the VOR with a magnetic course of 229 degrees. If you're using VOR equipment, you plug in 229 degrees for your outbound. It doesn't matter if the variation has changed in the area or not, you still plug in 229. Keep in mind, if variation changes in the area, they don't automatically go back to the VOR and recalibrate. So you just keep it on 229 for your equipment, and that's going to get you on the course that you need to be on. If you're using GPS equipment takes into account all sorts of things, right? And then is more easily updatable. So your GPS equipment might tell you its course, for example, 231. And your GPS would automatically lay in the proper course for that airway, and you would use that. Okay, so it just depends on which one you're using as to, do I just use the GPS course, even though it's different from the published one here? So yep, use GPS course. Otherwise, just use what's on the chart for a VOR navigation. Looking at your maximum elevation figures in your quadrants, they are determined based upon one of two factors. You don't know which factor they've used to determine them. We're going to cover both so that you're aware of what they are. It's entirely possible you may get asked this type of question on your commercial pilot check ride. Even higher probability on a flight instructor check ride. So this is good information to know. The maximum elevation figure starts off with a measurement of whatever the obstacle is. And we're talking first a man-made obstacle. So whether it's an antenna on a hill, a tall building in a city, man has built something and has measured it. There are a variety of measuring methods. Regardless, there could be some error with that measuring device they're using or the method they're using. So they allow for a 100-foot vertical air allowance. And what's happening is they're taking those two numbers and adding them together. So that would come up with 4,839 feet. And then they're rounding up. And they always round up to the nearest hundreds. So in this case, they round up to 4,900 feet, and that gives us the big 4 and little 9 figure in the quadrant. That's what gets published there. So if it's a man-made obstacle, you have a minimum of 100-foot clearance above it, plus any rounding. Remember, this is a different concept than your instrument en route chart for the OROCA altitude, which gives you 1,000-foot or 2,000-foot obstacle clearance, right? Maximum elevation figure on the VFR chart only gives you at least 100 feet above obstacle. It's entirely possible that you're in a part of the country where there's no man-made obstacles that high, but there are natural obstructions. And so those also get measured. If we take an example of 7,188 feet. So it's a ridge, mountaintop of whatever it could be. There's also the possibility that the measuring method has introduced a small error. So again, they allow for that 100-foot vertical air allowance. Now, according to charting rules, any man-made obstacle that's less than 200 feet does not need to be charted. So because of this, an allowance is made of 200 feet. Because even though it's a natural obstruction, if I have a small antenna, say 150-foot antenna, it's not required to be charted. So that is also taken into an account for determining maximum elevation figure. So again, these numbers are all added together, the elevation, the vertical air, and that 200-foot allowance. That would be 7,488 feet. Again, round up to the nearest hundreds. Gives you 7,500 feet. In your quadrant, you'd have the big 7, little 5. So this means if it's a natural obstruction in your quadrant, you have a minimum of 300 feet clearance with it. Again, you never know which one of these methods they used for your quadrant. All right, let's see if you have any questions here. All right. How often are VORs updated to ensure magnetic correctness? Not very often, to be honest with you. If the VORs is part of the minimum operational network, it will likely be updated. All the other ones are not going to be updated. They're going to be decommissioned. That's something to keep in mind. And your question might be, how often are they going to update those on the minimum operational network? I don't know. I haven't found anything that's published that tells me how often they do that. Nav quiz answers. Can we go over those? All right. Let's see what kind of time we have left. towards the end here. Any other questions? Any other verbal questions? Yes.
So on this chart here, the printout, we're not using the nautical model for a plotter, we're using the statute model, and or is it the other way around?
You're still, with the piece of paper that you use to measure it, you're using nautical miles with it. Your plotter is probably not going to work on that. It's not scaled to it. It could be scaled to it, but it's most likely not scaled. And you could check that scaling by putting your plotter up against a line of longitude and seeing if the tick marks line up every 1 nautical mile. Other questions?